Hello, I'm Daniel. My name's not actually on here. It's a bit weird. So this talk is primarily about digging deep and going quite low level in the design of a model. And are you guys all iOS? Are you people here iOS? Or some Android people? So I've spoken to a lot of Android people and talked about this talk with other languages, and hopefully a lot of the concepts will translate to other languages. So the concepts that Swift really is very good at providing answers to, but a lot of other languages are providing those answers too. So you can use these kind of patterns in other languages. So my expertise is with Swift and iOS, and I used to do Objective-C. Don't so much anymore, which I gather is kind of the trend. And this is going to talk about how Swift has empowered us and made a lot of the conventions that were in Objective-C much more... It doesn't like when you do things wrong, right? So what do I mean when I say convention or a pattern? Generally, any practice that you do in your code which is documented or potentially not documented anywhere, say on Jira, in a wiki, Confluence, a README, some note that you handed to your colleague. Any of that stuff I would call a convention. That's something which isn't necessarily adhered to by the code, but is something which we all kind of understand to be true most of the time, hopefully. An example of this might be a network request and your back-end guy saying, this is going to return a number, but it actually comes through as a string. And they're saying, it's definitely going to be a number inside that string, but you can't treat it as a number because it's a string, right? So that's one area where this is a convention. One day that server might decide to return you a string, but not a number. So as I said, Swift helps us because Swift is opinionated. It's so much more opinionated than Objective-C. Objective-C was kind of free and easy with things. It was like, you can do whatever you want, and I'll try and do my best. It'll be fine. For instance, in Objective-C, initialization was very much like, well, this is what you should do. But if you do something wrong, I'm not going to tell you about it. And maybe I'll break later, but you won't know why at that point, because it will have been ages ago that you actually did something wrong. So Swift, we have this notion of convenience and designated initializers, and the initialization flow in Swift is very much the case that you have to do things in a certain order. Otherwise, you get an error. In Objective-C, it would be fine, but kind of problematic. In the same way, we have mutable and immutable types in Objective-C as a convention, and they kind of came from the Cocoa frameworks rather than the language itself. And in Swift, it's defined with var and let. You can't change a let if it's a value type. And if you do, Swift will throw an error. In Objective-C and C and almost every other language, or a lot of other languages, there are so many ways to reference nothingness. Nil, null, ns null, an empty string, an empty array, an empty option set, -1, int max, int min. These are all ways that I've seen that can represent this idea of nothing. But optional in Swift kind of just rules all of those out and says, if you want nothing, this is what you use. And on my last example of Swift being very opinionated is with properties. So in Objective-C, we'd write title and set title methods to override properties and maybe get into what they're doing. To write custom getters and setters, in Swift, we have to write it like this. And that's defined, and that makes everyone adhere to that same pattern. So Objective-C, everything was done, and you kind of like, if you saw some Objective-C that was done wrongly, you would go, well, that's a bit wrong. But you would never have any reason as to why. In Swift, if something's done wrongly, you can go, well, it's wrong because the compiler says it's wrong. And Swift, if Swift is so opinionated, then maybe the code that we're writing should be just as equally opinionated about itself. So that is such an important notion that I decided to quote myself, which I just said, maybe our code should be more opinionated. A lot of code that I see, so I go onto projects, and I'm a contractor, so I tend to go into projects which are on fire. And if they're not on fire, they may become on fire very soon. And I'm brought in to kind of deal with that. And a lot of the time, the code is there, and it's been generalized to the point where anything can be accepted and anything can be valid up until the point at which it's used and displayed to the user, in which point you need to go, okay, well, if I've got this state, then we'll do this, and if I've got another state, I'll do something different. And these assumptions have to be made by the views or the view controllers or the view models or any other, that end of the spectrum or of whatever pattern you're using, architecture you're using. But essentially, all you're doing is spreading the burden of making that assumption right up to the viewpoint. Maybe we should be making that much lower down in the model end, where we can test and make sure that those assumptions don't spread to the rest of our code base. So for the rest of this talk, I'll be talking about this really simple example. So this looks like a fairly harmless type. It's only got 9 properties, so what could go wrong? Most of this talk, we're going to talk about this, but unfortunately I don't have anywhere to display it, so kind of make a mental note of what the structure of this is. We imagine we're making a drawing program, and inside we're going to use a rectangle to define a rectangle in this drawing program. It's going to have an identifier. Maybe we want to cross-reference it. Maybe we want to duplicate this rectangle somewhere else and draw it in 2 different places, so we want to make sure that the identifiers are the same. We've got an X, Y, width, and a height, kind of standard stuff, and red, green, blue, alpha to determine what to fill this rectangle with. And you'll notice all the types, the identifiers are string, and all of these types are doubles because they can be floating point values on the canvas. So the first thing that's kind of, I look at this and I would say is a little bit wrong, is that you could want to change the X and the Y positions at the same time. And for this, we want to talk about something called atomic types. And they describe properties which can change together. So it's unlikely that you want to change the X position of this rectangle and the red component of the color. However, at the same time, it's feasible that you might want to drag around the rectangle on the canvas, and the X and the Y position, the X and the Y coordinates would change it at the same time. If the model that we saw kind of changed for every property being set, then every time you moved it, you would change the X position, which would cause a save, and then change the Y position, which might cause a save again. And then you've got kind of 2 points on the undo stack. So when you press undo, it only moves one of the points that you moved, but you went from here to here. You didn't go here, here, and then here. We want to save the position as 1 so that when it's being dragged, when it comes to undo, we just undo that complete position change. And that's kind of the notion of atomicness here. So we might create these separate types to represent this individual information. So here we've broken it down into position, a size, and a color. And the position is just our X and our Y, the size is the width and the height, and the color represents our red, green, blue, and alpha. Each of these can change independently of each other, but it's unlikely that you'd ever want to change them together. So maybe you're readjusting the size of the rectangle by just pulling on the corner and resizing it, and that would change the width and the height at the same time. Maybe you're dragging it around and you're changing the X and the Y at the same time, or you're just setting a color from a color picker, and that's setting red, green, blue, alpha all at the same time. And then if we pull this back into our rectangle type, the rectangle looks a lot simpler. As I said, any of these properties can change as one thing. And conceptually, it's kind of easier to think about positions and sizes and colors on this type. And you might want to use those things in other places. which means you can add logic to those individual types without having to kind of maybe do an extension on a double, which would be fairly bad, because then you're giving that functionality of positioning to every double in your app. So that's our first kind of refactor of this rectangle. The next thing to notice is that the identifier is a string. And for this, I want to talk about something I call type specialization, a word I wish that was easier for me to pronounce. We basically want to take the identifier and make it less useful. Because string is a very useful type. String has the ability to map every character to a different character. It has the ability to truncate it, turn it backwards, capitalize it, lowercase it. There's a load of different things you can do on it. For instance, this is a completely valid thing to be able to do to our identifier. We could take the index after the start index and the one before the end and replace that subrange with nothing. So we could just trim off the first and the last characters of the string. But would that become a valid identifier in our system? Unlikely not, right? If something else is referenced in the identifier and suddenly this identifier has changed, it's likely that this becomes an invalid identifier. So we probably want to wrap this identifier in a type which we control, which can't do as many things as string can. Using these primitive types, I've recently learned there's a code smell called primitive obsession, which if you're using string for everything, is possibly a code smell that you have. I didn't realize this at the time of writing the talk. Well, most of the talk. So we could do something like this, where we make a type that is very specific, and it says, hey, I'm an identifier. I can be initialized with a string, and that's all I do. Okay? And there's nothing else it can do. So if you ever have an identifier in your system, you're like, well, I can only ever use it to set as an identifier on that rectangle or other things that take identifier. Maybe I have a find rectangle function on my canvas, which takes a rectangle's identifier, and I can pass it this. But I can't pass it anything else. It has to be one of these identifiers. You'll note that the value property here is private. So you can't even get at what the string is. You can only see that you've got an identifier. You want to kind of contain as much of that logic as you can to stop the outside world peering it in. In this case, I've added equatable so that we can just see whether two identifiers are actually the same identifier. And that's probably better than exposing the value itself and allowing a user to say, are those two values of the identifier equatable? Or equal, sorry. You could go a little bit further and say, this is how you initialize an identifier and create a new one. So here I'm just using UUID to create a new unique string. And this means that you can just create a new identifier, and that kind of solidifies what the identifier is in the system. So you can generate this from a number. You could have incremented numbers, but you don't need to know, the outside world doesn't need to know how you're doing it. And again, bringing it back into our rectangle, we can just create the identifier, and that's completely valid now. So I've also realized that frame has become there. That was an old version of this example. Please pretend that says position and size. So now we've got this rectangle, and it's got 3 different types inside, and we can kind of go and expect those types, and we can validate that all those types are correct, right? Probably not. So if type specialization creates types that have fewer abilities, then this next part is about constricting what their values can be. So it's completely plausible that some developer could come along and be confused about what they need to input for red, green, blue, and alpha. After all, it's just a double, so they could put in anything that they want. And this color here, they're probably trying to make our lovely orange, which fails on slides so well, using 100% red, 50% green, 0% blue, and 100% alpha. Obviously, a fundamental misunderstanding has happened here, and the developer knows what they want to do, but they don't know how to specify it. So the use of it is not as documented as it could be. In fact, maybe it is, but it's on a wiki and they haven't read that page. So how do we get around this? We could tell them to read the document, but no one's going to do that because developers don't read documentation. I mean, they barely write it, so reading it is beyond us. We could solve it by just throwing a fatal error if any of this stuff is wrong, right? So if you're providing something that's less than 0 or greater than 1, that says fatal error. Sorry. I think that's the only one. We just crash. And that's awesome because we haven't got an invalid color. Like, the developers, they can't make these invalid colors. They can only make valid ones. However, in this case, it's plausible because we're making a drawing app that the user is able to type in the colors. And maybe the user can type in 100 for the red value and then crash the app. And apparently that doesn't fly these days. That maybe used to fly back in the day, but now we care about UX and users being happy and providing valid states for, rather than letting users go and crash your app all the time, maybe we should just wrap it up and say, hey, we don't think you meant to do this. So we could validate using minimum and maximum values, right? We could say for the red, if you're greater than 0, then make red 0. If it's less than 0, make it 0. If it's greater than 1, make it 1. Otherwise, use the value that was given in. And then we could switch on green and say if it's less than 0, make it 0. If it's more than 1, make it 1. Otherwise, set it to the value that's given in. And we could do it for the blue. And if it's less than 0, and you get this, right? This would give you a completely valid color, but it's a little bit tedious to write. And it doesn't really give us that benefit of being self-documenting. So when the developer comes to it, they'll probably still try to make a color with 100, 50, if they're not used to systems where they're given between 0 and 1. So how can we solve that problem? Well, we can make a percentage type, which, again, uses a private value and takes a value and does the switch inside it. And then by using this, we can set the color to have percentage properties for each of the red, green, blue, and alpha. And now when you look at this, you go, oh, that's a percentage type. And if you know what a percentage type is, then you'll understand this code and you'll understand what you need to put in. And if you don't, you'll be able to just kind of click through and see how percentage is implemented and go, right, okay, yeah, if it's less than 0, it'll be capped at 0, and if it's more than 1, it'll be capped at 1. But there's probably a load of other places in your app that can use this type. And once that becomes defined, it becomes as useful as double itself, right? So if you see percentage in your app, maybe you'll know what that does. It also makes the logic of color fairly trivial because there's no logic here anymore because they're just taking valid percentages. And we're kind of moving that down into as low as possible. So when we're creating a color, we can create it like this, right? We can give it a percentage of 2, or a percentage of a half, percentage of -1, percentage of 100, and these will all be valid because they'll be capped. So what we'll actually get is a red of 1, a green of 0.5, a blue of 0, and an alpha of 1. And we won't have to do anything about it, just magically kind of happen. But this is kind of a little bit ugly, right? We're writing Swift, and this is really ugly. So Swift provides us a really nice set of literal types, which if you extend percentage and implement them, then you'll be able to actually create these things from literals that you type. So here I'm conforming percentage to expressible by float literal and expressible by integer literal. And that means that anytime we type a float or an int as a literal, where something wants a percentage, it will do that for us. It will go through these initializers and create a percentage value. So now we'll be able to just create a color with 2, 0.5, minus 1, and 100. And behind the scenes, Swift goes, okay, well, red is a percentage. So we'll go through the initializer for percentage using the expressible by integer literal and create a percentage and then give that to color. And then, as I said, what you end up with is a color where the red is 1, green is 0.5, blue is 0, and alpha is 1. Now, in other places, say where you've got a user inputting values, you still need to go through your default initializers. You still need to create a percentage to then put into the color. But if you're typing it in code and providing maybe default values for colors or tests, then this is a really nice win because it kind of looks like you're providing just a number, but behind the scenes, you're getting all of that type safety of going through your percentage initializers. So you might have seen the size that we had, and that took doubles as well. And maybe we can improve that by making a new type to represent the width and the height. Because what is a rectangle with a width of -1? Okay? Some systems mean that draws backwards from the origin. On some systems, it's just capped at being 0. So maybe we should improve size itself so that we know what's going on. And in this case, I've chosen to write a positive value, which when you click in, you can see that when you provide something that's less than 0, you are actually setting it to 0. So you can never have a positive value which is less than 0. And there might be some people in the audience who would disagree with my naming scheme here and say that actually this isn't positive, but it's non-negative. But yeah, sorry. Non-negative, I tried non-negative as a type name and it's just horrible to read. So I went with positive and I'm kind of much happier with myself. But, you know, technically I'm wrong. But this allows us to make sure that size is defined and correct every time we use it. And again, we've got one of these raw types that we can do all the expressible by int and string float literal with and get all of our type safety. So we've talked about creating types that have fewer abilities, and we've talked about constricting the values that they can have. I'm just going to briefly mention about removing invalid states completely. So what might this be? So for example, we have a great idea that maybe we shouldn't just support filling a rectangle with a color, maybe we should support a gradient. And this, I've got a basic gradient type, which has a start and an end color. And one beautiful thing that I think, if you look at this, is quite nice, is that we're starting to use our kind of these data types that we're using in multiple places. So once you start building up these, they get used in more and more places, but they're still strong and they're still providing that same foundation. So we haven't had to redefine what a color is, we're just reusing it here, which is nothing majorly groundbreaking, but I still find it fascinating that we can do this and build up these building blocks. And we've made sure that a gradient is atomic, it's a specialized type. There's nothing here that can be illegal. You know, it has to have a start and an end color. But what more? So yeah, gradient itself is defined, and we're pretty happy with this, right? Maybe it's not completely complete what you want. Maybe you want color stops, but we've got a start and an end. That'll do us for the moment. And putting this into rectangle, maybe say, well, okay, rectangle doesn't just have a fill now, it has a gradient. So sometimes you have fill, sometimes you have gradient, right? Like, this is completely fine. Except, what if fill and gradient are both set here? What do we do? What happens if they're both nil? So let's try to reduce this from ever happening, or prevent it from happening, by creating an enum called a style, which can have multiple options. So I've even added a third option for a radial gradient, just in case anyone's a massive fan of tie-dye. So we could have a fill color and a linear gradient or a radial gradient, and the rectangle itself can be styled with these. And it can't have an invalid state. It must have either a fill, a linear, or a radial for its style. You can't say, and when you're drawing it, it means you don't have to make any decisions, right? So you can just switch on the rectangle style and say, well, if it's a fill, I'm going to fill it with a color. If it's a gradient, then I'm going to fill the gradient in either the linear or the radial way. There's no second guessing what's needed here up at the view layer, because all of this is defined in the model. And that's kind of what this is all about. Bringing all of that down so that you just can't bubble up invalid stuff to the rest of your layers. So I've mentioned it a couple times, and we're going to talk about how to use this with validating user input. So a lot of apps will have validators. So as data comes through, they'll validate it before putting it into the model. How about maybe the model validates its own input, and then you don't need a validator, and actually that model can never be invalid, because if you've given it an invalid state, it can't create itself. So let's think for a second about a percentage which can be initialized with a string. So this is the case where you've got the red, green, blue alpha values as text fields on your user interface, and the user's inputting a string for the percentage value of each of those components. And here we see that, if the double can't be created to initialize the percentage, then we just return nil. So the percentage can't be created if the double can't be created, and that would be fine, right? But there's no feedback to the user. So maybe we want to provide a throwing initializer, which provides much more a clearer reason as to why something can't be initialized. Here, I've just suggested that if it's not within this character set, then the string is invalid. But we could add more cases here to provide more feedback to the user. And at the end of this, what you get is if you try to initialize a percentage with 4, there's no error. This is completely fine. If you try to initialize it with an A, I don't know what percentage this means, you would get an invalid character, and 0.0.0 is, well, we don't know why, right? I mean, we do know why. That's not valid, but we can work on these errors. If people are continually inputting 0.0.0 into the text field, then maybe we want to handle that special case. So validation becomes really easy when the model cannot accept and can't be invalid. The validation happens as part of that model's initialization, which really just kind of cuts away a big swathe of what of your validators and that whole part of logic, and brings it in line to a model which is completely testable, and as I said, means that the UI doesn't have to deal with these problems. So let's talk about restricting APIs. So this is all, I've not really used any of the I've not talked about the making things private, or I have in terms of the value, but not in terms of the API. So at the moment, it's completely possible that in some other part of your app, you could extend percentage and create a custom initializer for it. And here we're saying, hey, just set you to a bad value, and it's kind of cool. This would be completely bad, right? Because it undermines all of that type safety that we've been building up, and all the value safety and all of that. So how do we get around this? And in Swift, the answer is now, at least, quite simple. We can bring these types into a custom module that only they can initialize the values, and every external module will need to go through those initializers to be able to create them. So this was only possible. Is only possible really to be guaranteed from Swift 5. From 4.1, it's a warning, and basically this evolution proposal to restrict cross-module struct initialization, which says if an initializer is declared in a different module from a struct, it must use self.init blah 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 or self equals blah 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 before returning or accessing self, which means you can't create an initializer which does what we said before. So we just can't create that. If the percentage is defining a module, then you must call the initializer that you provide from that module. As I said, this isn't currently an error, but it will be in Swift 5. And definitely if you saw it about your code, you would think that's a really bad place to be. So some final thoughts. I've kind of been designing these types of models, not just in terms of the types that we saw here, but kind of model layers in general to be, this is the whole valid state that everything can be in. And generally, a lot of these talks happen right at the start of a feature kickoff, whereby we sit down and maybe have people from UI and UX and business analysts and product owners, and we all sit down and just say, look, this is the data that we're getting in from a server. What is valid in this situation? If this particular property is nil, and we don't have it coming down the wire, what should we do? And sometimes the answer is, well, if you don't have an identifier for that product, you probably shouldn't display it, or you probably shouldn't even try to go any further, because every product should have an identifier, so just fail the request, because it's just an invalid response. It shouldn't happen, right? Sometimes properties just don't exist on some products in your API, or some things that come down. So you can say, well, in that case, we'll just make them optional in the model, and that's fine, and that's also a solution, right? As long as everyone's on board with that. What it does is it raises these questions about edge cases up front when you're actually designing the system. So you don't have to write the assumptions later in the view or the model, the view models or the view controllers. And this also means that that kind of logic can be split out to another module, so that our data layer doesn't actually know about the stuff that's coming in. So we can split up all these separation of concerns, say this is where the conversion happened. And that conversion isn't just converting from one type to the other. It's our assumptions about that data that's coming in. We can make sure that those assumptions are kind of okay on everyone, for everyone, right? For UX and business. And it allows everyone to have a say in it before, we go off and do things. And that's all I've got to talk about, really. So thank you.
Let's say that you'll create a lot of this, like, small models to basically mimic the behavior of simple stuff in Swift, yeah? And aren't you afraid that you're basically creating an abstraction around simple values that are available in Swift? And for example, if some new young developer comes that does not yet understand this abstraction because RTFM rule does not apply, and he will basically try to change something. Mm-hmm. And that might bubble up very quickly.
Yep.
So aren't you afraid that this is actually quite easy to achieve? Like breaking the whole system because the whole abstraction is invalid.
Yep. I think if you don't have trust that people are going to do that, then there's a kind of bigger problem. If you've got new developers coming into Codebase where they can do that, then that's a different problem. I think you can pair with these people, or you do code reviews and with people that already know the code base, so they should see that stuff coming through. I do think with enough tests, it should be visible when something like that is broken. So if you were testing your model completely, then they would have to change that model, change all the tests, possibly change other places where that's used. Suddenly you're looking at something which doesn't look like a kind of quick thing that they've done, but they've kind of like destroyed half of the code base to achieve it. So I get that, but I think you can also be fearful of anyone changing any code and destroying assumptions there too.
Yeah, it's just, because like you showed the quit early example with guards.
Mm-hmm.
Yeah. So I imagine that it's quite easy to basically, there's a production bug and you need to fix something because it's crashing, and young developer will basically change the return value to nil. And as we all know that if it's basically assigned to optional, then nothing major will happen, but at some point it will basically cause the app not to respond or something.
Yep.
So I just fear that this is actually, that might happen and tests might not catch up this. Because you imagine that, you can see that this type was supposed to be created because the init is quite simple.
Mm-hmm.
Yeah, and aren't you like afraid that creating all of those types will basically enlarge the amount of files that we have in a project? And we know that Swift is not like, it does not have like a quick compiler. So
On that, actually, what I found is that it reduces the amount of files, or over it reduces the amount of code because you're only doing logic in one place. So if you look at the color, you could assert that every component is between 0 and 1, but you have to do that logic 4 times. But if you pull it down into a percentage, then you only have to do it once. So the amount of code is actually reduced. And I think you find that as you pull stuff down into raw types, the code actually reduces in size, not grows, which is kind of insane to me. Like, you would think it would grow, but it doesn't. And especially in terms of validators, a lot of code ends up being validating user input. And if that's all pushed down into the same logic that you're using to get from the server as well, then you've kind of reduced that code base, that code size as well. I get what you're saying about being fearful, but I think if we lived in fear of new people coming into code bases and changing stuff, then we would either never hire new people, which is, or live in fear for the rest of our lives, which maybe a lot of developers do.
What developers do.
Yeah.
Yeah, thanks.
Cheers.
I got 2 maybe trivial questions. First, could you clarify a little bit more about when operation is atomic in Swift, mm-hmm. or access to variable? And second one, what is the impact on performance of these features you described?
Right. So you are having like a small impact on just creating things because you're having to do these checks. Like that's definitely a thing that happens here. So every time I create a percentage in the system, I'm having to do a check to make sure it's between 0 and 1, and that's causing a hit, I don't know the big O number for that, but it's having some impact, right? And if I'm doing that a lot, obviously that's a lot of if checks that I'm having to do. My thinking is that instead of doing the if checks there, I'm doing the if checks, or instead of doing the if checks later on where I'm drawing, I'm actually doing it at the model creation. So to me, I think it's a better place to take that hit in this instance. And I think that would be the case in most instances, where if you do the if check at a model layer on the creation, you're able to do it on the background thread maybe, rather than doing it on the main thread when you're drawing. So I think actually it's just about moving the performance hit, as it were, to maybe a better place. In terms of the atomicity question, I don't have a valid answer for that right off the top of my head, but we can discuss it afterwards if you want.
I have a question about convenience initializer, which you created for percentage from string, because first it was failable and then you make it throwable. What is the benefit if you have only one possible error for that kind? Like, for instance, in URL, we are creating from string and it returns a new label of variable. Because we know that if you provide the wrong string, it just couldn't pass it to URL. The same for percentage. So still you have to do try, catch, produce more code, which brings no value in that case, from my point of view. So what's your opinion about that?
I needed an example for this slides. So I don't use that failure. So I do use these types in my app. But I don't use a failable initializer in that case because I just care about whether I have it or not from that user input. And if I don't, then chuck something in the text field that either don't accept it or chuck up an error saying that it's wrong or do something in the UI. There are types where that's potentially more beneficial. So maybe you've got an email address and you're doing some validation on that, although maybe you shouldn't do that. But there are lots of ways that email address validation could fail, and you could present that to the user.
Yeah, from my point of view, it makes sense if you have many validation points and many different errors, because then we can see what exactly went wrong. But if there is only one...
In this case, it was too simple of an example to, Unfortunately, a bigger example wouldn't have fit on the slide. Cool.
That's it.
Thank you.
Thank you very much.